In this lesson, you'll learn what really happens behind the scenes when JavaScript runs. Once this clicks, debugging, interviews, and frameworks like React will make a whole lot more sense. Every time you click a button on a website, JavaScript is running. When you open YouTube and comments load without refreshing the page, JavaScript is running. When Netflix updates your recommendations instantly, JavaScript is running again. But here's the key question. How does JavaScript decide what runs first, what runs later, and what gets stored in memory? That decision-making process is what we call JavaScript execution. Beginners read JavaScript line by line. Professionals don't. Professionals imagine an invisible system inside the computer processing their code step by step. Think of it like this. Writing code is like giving instructions to a chef. You don't see how the chef prepares ingredients, you only see the final dish. JavaScript is the same. You write code, but something else executes it for you. That something is called the JavaScript engine. The JavaScript engine is a program that takes your JavaScript code and turns it into something the computer understands. Your CPU does not understand JavaScript directly. It only understands machine instructions. So the engine acts like a translator between your code and the computer. In Chrome, the engine is called V8. In Firefox, it's SpiderMonkey. In Safari, it's JavaScript Core. Even though names differ, they all follow the same JavaScript rules defined by ECMAScript. Let's make this real inside your computer. Open VS Code. Create a new folder, JS Execution Model. Inside it, create 3 files, index.html, style.css, app.js. Open index.html and connect your JavaScript file. Now open this project using Live Server. Open Chrome DevTools using F12 and go to the Console tab. In your app.js, write this, console.log JavaScript is running. Save the file and look at the browser console. It looks simple, but behind this one line, JavaScript already performed several hidden steps before printing anything. And those hidden steps are what we call the execution context. In the next section, we'll build a mental model of how JavaScript prepares memory, organizes code, and decides how everything runs. Now that we know JavaScript doesn't just run code directly, the real question is, what exactly happens before your code even starts executing? In the next part, we'll open the JavaScript engine and watch how it creates memory, stores variables, and prepares everything before execution begins. Now we're going inside the JavaScript engine. This is where most developers get confused because nothing here is visible in your code. But everything you've ever debugged comes from this exact process. We're going to break it into 2 phases, memory creation phase and execution phase. Once you understand these 2 steps, JavaScript stops feeling random. Every time JavaScript runs a file, it first scans your entire code without executing it. It prepares a workspace called the execution context. Inside this workspace, JavaScript creates memory for variables and functions. Let's see this with real code. Before running line by line, JavaScript already stores memory like this. This is why we get something called hoisting. It feels like JavaScript moves variables to the top, but actually it just allocates memory first. Functions are fully stored. Variables are initialized as undefined. Now here's where beginners get confused. They expect this, but what actually happens is this, undefined. Why? Because during memory creation, JavaScript hasn't reached the assignment yet. It only knows A exists, not its value. After memory is prepared, JavaScript starts executing code line by line. This is called the execution phase. Now it assigns values and runs functions. Let's continue our example. First, A already exists in memory as undefined. Then JavaScript reaches A equals 10 and updates the value. Finally, console.log A prints 10. Now let's talk about something every interview loves, the call stack. Think of it like a stack of plates. You add 1 plate at a time and remove the top one first. JavaScript uses this system to manage function execution. Let's see it in action. Here's what happens step by step. 1 first is pushed to stack. 2, console.log first runs. 3, second is pushed on top. 4, console.log second runs. 5, second is removed. 6, first is removed. This is why JavaScript is called single-threaded. It can only handle one thing at a time using this stack. Now let's switch to how professionals actually debug this. Instead of guessing, they inspect the call stack directly. Open DevTools, go to Sources, Set a breakpoint on your function. Now step through the code line by line. You can literally watch JavaScript executing in real time. This is how senior developers find bugs in seconds, not minutes. If you master this mindset, debugging stops being stress and becomes exploration. Now you understand how JavaScript prepares memory, executes code, and manages function calls using the call stack. But there's still one missing piece. How does JavaScript handle real-world applications like APIs, timers, and async tasks without freezing the browser? In the next part, we'll break that illusion and discover how JavaScript really behaves in real applications. So far, we've seen how JavaScript executes code inside the engine using memory, execution, and the call stack. But here's where things get interesting. Real applications don't run line by line only. They wait for timers, fetch data from servers, and react to user actions. So the question is, how does JavaScript handle time-consuming tasks without freezing the entire page? Most beginners think JavaScript runs alone. It doesn't. It runs inside the browser environment. The JavaScript engine is just one part. The browser gives it extra powers. These extra powers are called web APIs. Things like timers, DOM events, and network requests are not handled by JavaScript engine itself. They are handled by the browser, then passed back to JavaScript when ready. Let's look at a simple example that confuses almost every beginner. Many people think output will be start, timer done, end. But JavaScript doesn't work like that. Here's what actually happens. First, start prints immediately. Then set timeout is sent to the browser web API. JavaScript continues executing the next line without waiting. Finally, end prints. After 2 seconds, the browser pushes the callback back into JavaScript, and only then timer done is executed. Now the question is, who decides when that callback gets executed? The answer is the event loop. Think of it like a traffic controller. It constantly checks, is the call stack empty? If yes, it pushes waiting tasks into the stack. That's how JavaScript stays responsive even while handling delays. Without the event loop, every website would freeze whenever a timer or API call happened. Now let's see where developers actually struggle. Beginners often write async code and expect immediate results. Even with zero delay, B does not run immediately. Why? Because it still goes through the web API and callback queue. The call stack must finish first. This is one of the most important debugging skills in real applications, understanding execution order. Senior developers don't guess. They trace execution flow using breakpoints. They ask, what is in the call stack right now? Let's apply this to something real, a loading button like you see on YouTube or Netflix. When you click it, the UI shouldn't freeze. It should show loading first. When you click the button, JavaScript does not freeze the page. It updates UI immediately, sends tasks to web API, and continues. This is exactly how real-world apps stay fast and responsive. In interviews, you'll often get this question, explain the event loop. Most developers memorize it, but interviewers are looking for mental clarity, not memorization. If you can explain how call stack, web APIs, and callback queue interact, you already stand out as a strong candidate. Let's lock the entire mental model in your brain. Step 1, JavaScript creates an execution context. Step 2, memory creation phase stores variables and functions. Step 3, execution phase runs code line by line. Step 4, function calls are managed using the call stack. Step 5, async tasks go to web APIs, then callback queue. Step 6, event loop pushes tasks back into the stack when ready. That's it. That's the entire execution system of JavaScript. Everything else, React, Node, frameworks, runs on top of this model. Let's talk like real developers now. When something breaks in JavaScript, professionals don't panic. They observe execution. They ask 3 questions. 1, what is currently in memory? 2, what is in the call stack? 3, what is waiting in the browser queue? Most bugs are not JavaScript bugs. They are execution misunderstandings. That's why DevTools is your most powerful skill, not syntax. If you can explain execution like a system, not a sentence, you instantly stand out. Especially in companies like Google, Amazon, and modern startups, this is considered foundational knowledge. Now, you don't just write JavaScript, you understand how it thinks. In the next episode, we'll break one of the most misunderstood topics in JavaScript: variables, memory, and hoisting, and why most bugs actually start there.